Hey everybody, welcome to Unit 5, Week 4. Here we go. It's Kernu time. Just kidding. But make sure you like the video and you subscribe below. Sorry, just had to do it. All right, guys, we are going to be starting Unit 5, Week 4. Oh gosh, crazykins. So in order to start, we're going to watch the introduction video, and then we're going to learn some vocab. We're going to go over the skill, and we're going to read the story. So hopefully you guys enjoy this wonderful, wonderful selection.
Now we know. How can scientific knowledge change over time? Many of us have used a microscope to get a glimpse of worlds that might be hidden to the naked eye. With the help of a powerful electron microscope, we can see the complexities of caterpillar feet. To look far out into the universe, we can use a telescope. The Hubble Space Telescope helps us to see even farther and with greater detail.
Pretty cool.
We can even see the sun in action.
Whoa.
With more improvements in technology and equipment, what else do you think we might learn?
All right, guys, so that's our introduction for the week. So we're going to be talking about how our interpretation of scientific information has changed over time. Okay. All right, so we're going to be going deeper this week, which means we're going to be not just looking at something from the surface, but we're going to be changing our perspective and looking at how things have changed over time. So if you look at this picture right here, you can see that this would not have been possible 100 years ago, 200 years ago. This is because technology has evolved and changed. So scientific knowledge has definitely changed over time. Just ask your parents to show you their cell phones from long ago. You'll definitely see some very interesting things. So, all right, we're going to take a look now at our selection and our vocabulary and our skill. All right. La, 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 bum, bum. Okay. You guys know I love my technology, guys. All right, so I'm going to bring it back a little bit here. All right, so these are our vocabulary words for the week, and we have 8 of them. So the first word is approximately. The word approximately means about. So if I said I put approximately 1 cup of flour into the mix, I put about 1 cup. It wasn't just exact. I didn't get out the leveler. So approximately is like an about, a guess. All right. Astronomical. Astronomical means anything that has to do with space. So anything that has to do with the sun, the stars, the moon, anything you can say is astronomical. So if you're looking at this child right here, it says the space exhibit included amazing astronomical instruments to study stars. So that instrument has to do with space. You can use it to view space. Pretty cool. All right, our next word is kind of a math word, but it makes sense because we're talking about science, and science and math are like long-lost brothers. So we have calculation. Calculation is when you figure something out mathematically. Mina did a quick calculation to figure out if she had enough money for 6 tickets. So she just did a quick little jot down to see what she had. So what kinds of skills help with a calculation? What do you need to know in order to do a quick calculation? I would certainly hope that you have some quick addition, subtraction, multiplication, division skills, so you're able to go like this, right? Figure that stuff out. All right. Ooh, my Math 24 folks would be really good at calculations, and quick calculations at that. All right, criteria. Criteria is a way of judging something. So blood pressure is one of the criteria doctors use for evaluating your health. It's kind of like when we look at a rubric and I say, okay, it needs to be creative, it needs to have this, it needs to have that, it needs to have that. That's criteria. That's the rules you need to follow in order to have a good product. What What other criteria might your doctor look at to check your health? They might check your eyesight. They might check your hearing. They might look at the oxygen levels. They might check your heartbeat, your lungs. So criteria is a way to check to see if something is measuring up to what it's supposed to be. All right, the next word is diameter. Diameter is when you measure something across, specifically a round object, like a circle. So the diameter of the pizza is 14 inches. That means from one edge of the crust to one edge of the crust, that pizza in between is 14 inches across. Okay. Next word is evaluate. When we evaluate something, we judge it. So if I look at, it's not my regular Dr. Pepper, but if I'm looking at my Diet Pepsi, I might evaluate the nutrition value and say, well, it's 0 calories, but there's a lot of sodium in this. That might not be good for my health. So when you evaluate something, you look at what are the benefits, what are the negatives, and you figure out, is this really worth it? All right, so next word is orbit, and orbit just means that you are circling around something. So they gave the example of it takes a year for the Earth to orbit the sun and a month for the moon to orbit the Earth. So when things are orbiting, they're going around something else. So my Diet Pepsi can is orbiting my head. Whee! All right, next word and last word for today is spheres. A sphere is a three-dimensional round shape, so something like a basketball, a soccer ball, a baseball. Those are all spheres. Football's not a sphere, okay? So these are the words that we're going to need to use in order to read our story this week. All right, and here it is. Boys and girls, this shared reading is expository text, which means we are going to be learning facts and information about a certain topic. Thank you, Patrick, for being a ninja.
I don't know where my computer is.
Honey, I'm in the middle of a lesson, so you're going to have to figure that out. Okay. Hi. Hey, everyone. All right, so back to what I was saying. Expository text, we're going to see things like diagrams, photographs, headings, things that are going to specifically teach us about the topic. So if I'm looking here, I see a heading, I see a diagram, I see a real, you see here, yeah, we got like an illustration here. Sorry, Miss Carney's eyes are just like a mess right now. Yeah, we got another diagram. This is wonderful. So there's a lot of things here. We have captions, lots of things here to help us understand what we're reading as we read the information. Now, our skill and strategy for the week. We are looking at asking and answering questions. So as we read, we should be thinking of questions. We should also be asking questions of the author so that we can monitor our comprehension. And I'm going to show you what that looks like and sounds like. We are also going to be focusing on cause and effect. When we think about cause and effect, something makes something else happen. So I like to give the example of my alarm clock didn't go off this morning, so I was late for school. So the cause is my alarm clock didn't go off. The effect is I was late. Cause and effect relationships often form a chain, where one thing leads to another thing, leads to another thing, and leads to another thing. So we're going to look at that today, okay? All right. So if we think about my example of being late because my alarm clock didn't go off, the first thing was that my alarm clock did not go off. The second thing was that I was late for school. The third thing is that my mom yelled at me all the way to school. The fourth thing, I missed breakfast and I was hungry. So see how it's not just one thing leads to another. It's a chain of events. Okay? So now we're going to head on back. Now that we know all that jazz. All right. So now we're going to read Changing Views of Earth. Again, it's an expository text, which is going to give us facts and information. We're going to be on the lookout for those nonfiction headings. We're going to be on the lookout for those nonfiction text features like headings, diagrams, illustrations, captions, all that good stuff. So our essential question, how can scientific knowledge change over time? Read about how our understanding of Earth has changed along with scientific developments over time. All right, let's get started. On the ground, looking around. No matter where on Earth you go, people like to talk about the weather. This weekend's forecast may provide the main criteria for planning outdoor activities. I know I had a lot of fun outside this weekend. What did you guys do? Hope it was good. I hope you maintained social distancing. All right. This weekend's forecast may provide the main criteria for planning outdoor activities. Where does all that information about the weather come from? The ability to predict storms and droughts required centuries of scientific innovation. We had to look up at the skies to learn more about life here on Earth. That's pretty interesting that we had to look outward to figure out what was going on with us. I like that. Long ago, humans based their knowledge on what they experienced with their eyes and ears. If people could heighten their senses, they might not feel so mystified by the events confronting them daily. For example, something as simple as the rising sun perplexed people for centuries. Let me ask myself a question. I wonder what they thought was the reason behind the rising sun. What kind of explanations did they come up for that? Oh, let's see. They believed, here's one. They believed that the Earth stayed in place while the sun moved around it. This was called the geocentric model. And I can figure out geocentric because I know my roots. So geo means Earth, and centric means that it's centered around something. So if we say something is geocentric, that means it's Earth-centered. Does that make sense? So if they believe that the Earth stayed in place while the sun moved around it, that's geocentric. That means the sun is moving around the Earth. In the early 1600s, an Italian named Galileo pointed a new tool called the telescope toward the night sky. Oh, here's some new technology. I wonder how he came up with that. As a result of his heightened vision, he could see stars, planets, and other celestial spheres with new clarity. Oh, I wonder what that looked like back then. That'd be really cool. Such an amazing accomplishment to be able to see that. Each observation and calculation led him to support a radical new model of the solar system. In the heliocentric version proposed by the scientist Copernicus, the sun did not orbit the Earth. The Earth orbited the sun. So we went from a geocentric model, where the sun moved around the Earth, to now a heliocentric version. So I can figure out that heliocentric, helio probably means the sun, because now we know that everything goes around the sun. Very cool. All right, we have a diagram here. These diagrams show the geocentric, Earth in the center, and the heliocentric, sun in the center, views of the solar system. So you can see how they're different from each other and how that changed over time, whereas everything went around the Earth, so they believed, and then they figured out with the help of the telescope, not quite the case. Pretty cool. All right, let's take a look at in the sky looking down. That sounds interesting. New technology allowed scientists to evaluate theories better than ever. Measuring devices such as the thermometer and barometer offered new insights into weather patterns. However, people were still limited to ground-based learning. What if they could travel into the sky, where the weather actually happened? That's a pretty crazy thought for back then, huh? In the mid-1700s, some scientists sent measurement devices higher and higher. At first, they used kites. Before long, hot air balloons offered new ways to transport the tools. and sometimes scientists themselves into the sky. I wonder what that was like to be a scientist going into the sky like that. It must have been pretty scary, but exciting at the same time. However, scientists were not satisfied studying the lower layers of Earth's atmosphere. The more they learned, the higher they wanted to go. They also wanted to obtain information more quickly and accurately. Kites and balloons were hard to control. As a result, they occasionally veered off course or got lost, taking their data with them. The development of aircraft in the early 1900s promised safer ways to observe Earth's surface and the atmosphere above it. Kites and balloons could reach altitudes of approximately 3 kilometers. So I know that when we use the word approximately, it wasn't exactly 3 kilometers, but it was about. By comparison, airplanes lifted scientists to a height of 5 kilometers and more. Radio technology allowed scientists to transmit data from the air to the ground, where other scientists analyzed and compared information. Breakthroughs came fast and furiously. Still, scientists dreamed of reaching ever higher. So that makes me ask the question, I wonder where scientists are going to stop. So if they keep getting information and they keep pushing further and further, it's pretty amazing where they could wind up. Out in space, looking back home. So here's a new perspective. 20th century advances in aeronautics led to more powerful rockets that lifted satellites into orbit around the Earth. From these heights, scientists could study the composition and relative thinness of our layered atmosphere. Some meteorologists could analyze multiple factors at once. The accuracy of their weather predictions improved dramatically. I see a bit of a cause and effect relationship there. So the meteorologists could have analyzed their stuff better, so then their accuracy in reporting the weather got better. NASA launched dozens of satellites into orbit in the following years. Some stared back at Earth, while others peered deep into the endless space. They gathered astronomical data about the ages of planets and galaxies. Sensors and supercomputers measured things such as the Earth's diameter with incredible accuracy. Because of this technology, scientists could develop more reliable models about Earth systems. For example, they could form theories to show how climate might change over time. I did notice they use the word because here, which shows me this is a cause and effect relationship. So because of this technology, so there's the cause, the technology, the effect is scientists could develop more reliable models about Earth systems. Very cool. All right, let's continue. Space missions continue to venture farther from home. Even so, nothing compares to seeing Earth the old way, with our own eyes. Views of our planet from space inspire awe in nearly all people who have seen them, even in photographs. With all the arguments for going to the moon, said astronaut Joseph Allen, no one suggested that we should do it to look at the Earth, but that may in fact be the most important reason. Pretty cool quote. All right, so here below we have some questions for you to think about. What were some effects of flight on our knowledge about the Earth? And how has your knowledge of Earth changed over time? So think about when you were little, what did you think about Earth? What did you think about the planets and the stars and the sun? And what do you think about it now? It's probably a pretty big change. I know my mom used to joke with me and say that the moon was made of cheese. That moon is not made of cheese, but I'm sure it would be delicious. All right, so again, we talked about the fact that this is expository text. We learned about space, and we learned about the changing of technology and our knowledge of the Earth and our solar system. Oops, I went too far. Let me go back. Here we go. All right, so we also looked at asking questions while we were reading and thinking out loud, as I showed you by talking about what kinds of things did scientists use to make forecasts? Why did they do that? What were they thinking of? So constantly asking yourself questions, and then again, cause and effect, how one thing can lead to another, and then to another, and then to another. Okay? Just makes me think if go back here, so I'm going to check my text. If Galileo hadn't created that telescope, maybe the ball wouldn't have gotten rolling the way it did. So maybe we would still think that the Earth was the center of the solar system, that we were still looking at a geocentric model. So just one change can lead to so many different things. All right, guys. So I hope you enjoyed Changing Views of Earth. You have a vocabulary Google form that goes with this. So make sure you take a look at those meanings again and study, and then fill in that form. And then I also created a Nearpod for you. So make sure that you go through everything in the Nearpod so that you don't miss any questions, because some of you guys skipped questions on the last one. All right. Have a great week, and I look forward to seeing you guys again. Bye.